This is geotrig lesson 2, day 2. We're finishing with the area stuff of this very irregular shape. This could be overall at the end, could be a pyramid or a cone, so it could have some height to this, or it could be a building with a base that has those dimensions. We're going to get to volume next, but the biggest obstacle to finding volumes is defining the area, which is what we need to do first. I see, what, 4 different shapes on here? I see 2 half circles and 2 triangles. Nice thing about the triangles is what? Look at the triangle's dimensions. Even numbers. They share a side that's an 8. They both have a side that's 6. That means that third side also is 6 because, or not 6, sorry, 10 because this is a radius, right? So this is 5 over here, 5 over there. That means this whole thing is 10. These 2 triangles are the same. That's kind of nice. But that means all I have to do is just take all the different pieces, find their areas, and just add them up. So I have a semicircle, semicircle, triangle, triangle. And if I add all those, find each one of those, and add them up, I'm good to go. It's not a straightforward problem. But once you break it apart, then it becomes pretty straightforward what you have to do. This is what I'm talking about when we were taking the questions from the homework, was the fact that sometimes you need to take a step back. Instead of just diving straight into a problem and then saying, oh my gosh, I'm lost, I can't do this, and then give up without even trying. See if you can break it apart. Break it into manageable pieces. I think every one of us can find the area of a half of a circle and a triangle's. And we should all know that if I take a step back, that since it's made up of those pieces, I'm going to add them all together. So you kind of step back, I need to find area of different pieces and add them together. It gives me a total area. Now, each one of these circles, or half circles, have a different radius. What's the radius? One of them is 5. It tells us. What's the other one? It's 3. The dimensions of each one of those triangles. What's the base? Give me a base. 8. Then what's the height? 6. That's one of them. It doesn't matter which one you want to call it. Maybe it's this one. What's this one? Ooh. It's 6 and it's 8. Does that matter? No. Does it matter? They're both right triangles. So therefore it won't matter. You can't have the same sides and not have everything else be the same, right? So we definitely know that this would have to be a right triangle as well. So, using the formula, pi r squared and divide it by 2, right? Pi r squared divided by 2. Triangle? What is it? 1/2 base times height. There's my formulas. Figure them all out. Add them up. Pi times 5 squared over 2 plus pi 3 squared over 2 plus 1/2 times 6. This one's going to look slightly different because it'll say what? 1/2. And then times 8, correct? But remember, order doesn't matter. It's kind of nice that way. What's 5 squared? So, it'll be 25 pi over 2 plus
6 pi over 2.
9 pi over 2. 3 squared is 9. Plus, what's half of 8? Times 6. So, we know both of those are the same, so they're both 24. Again, our answer is going to be left in terms of pi. Notice 25 pi over 2 and 9 pi over 2 are like terms. And 24 and 24 are like terms. But together, they cannot be pushed together without making decimals. So since they have a common denominator, what's 25 plus 9? 34 pi over 2 plus 48. And whatever the units are, we'll just say it's centimeters. Centimeters squared, right? Now, you may want to put 48 first because it's a nice number. It's a rational number versus an irrational number. That is going to be a decimal, right? That's not going to be nice. The number overall is irrational. That's your answer. So we're going to move on to volume. Volume works in the blank dimension. Third. AKA, things are 3D. Yeah. It's probably capital D, huh? 3D. Examples of volume. Ooh. Rectangle is not a 3D. What's examples of volume? What's that? Prism? That's an object, right? It's a little harder. Point to something and say that's volume, or tell me what's volume.
Water.
Yeah. Solid objects. Okay, just solid objects.
I don't know how broad we go.
3D object.
3D objects. Something that has space, right? I'll just put space in there. Space is an example of volume. It has space, it has volume. It takes up something. Okay, we'll leave it. How do we calculate volume of the given shapes? Rectangular solid. Or a prism. Rectangular prism, they call it sometimes. What would that equation be?
Volume equals times width times height.
Yeah. A cube. Yes, we still can say it's length times width times height, but when it's a cube, they are all the... So a lot of books, or a lot of times they just put S for side, cubed. Because what they do is they say this is S, S, and S, versus length, width, and height, right? Ooh, a cylinder. Or a circular prism. What's the volume of this thing?
Height times base.
Yes. Or, what's the base?
Pi r squared.
Pi r squared, h. So, we just went through and gave us some examples of those three shapes. What's the common thread between all of those? Here, let me help you out. What's that? They're all examples of volume. They always add height. I wouldn't say add height. Add is not the right word. They multiply the height, or they multiply, height. A third dimension to it. What's all inside the red parentheses that I did there?
Length and width.
Length, width, s squared, pi r squared.
Main.
Areas. Areas of what? Where is the circle? Where is the length and width? Where is the s squared? All at the bottom, or the base. So, volume, guys, is area of the base times the height. I'll even put parentheses around. Area of the base times the height. This will work for any solid object or object that needs to hold something, a 3D object. If you know the base and it comes straight off of that base, you can find the volume. So, how do you calculate the volume of that given shape? Where do you think the base is? Is it laying on its base right now? So the bottom half down here, this kind of looks like a book, right? Laying on its side, is that the base? The question you got to ask yourself is, is it uniform all the way through?
No.
Where would it be uniform all the way through?
Yeah.
You've got to be more specific than that.
Yeah.
What does it look like to us where that it's uniform all the way through? This thing right here.
Yeah, square.
The square or that rectangular shape. I would say the front face, not the bottom. The bottom face is kind of underneath here. But the front and back look exactly the same, and it's just kind of like it's been stacked, right? One after another base. That's where the base is. And so that means you need to, wait a minute, that shape looks awfully familiar. Doesn't it? Didn't we do this in the last problem, or the 2 problems ago? We used numbers instead of x's, but we have 2x and 3x. I got a rectangle and I have a half circle. So how do I find the area of that? Because if I find the area of that, I multiply it by what? The height, which is y. It goes y deep, right? Off into the board. I think it's pretty easy to say, oh, area of the rectangle is 2x times 3x, right? Which is 6x squared. That's pretty easy for here. What's that? Pi x squared. How did you get that?
Because 2x is the new radius is half, so it's just x.
Right, the radius is x on each side. So therefore, it's pi x squared. And if I add those two together, I now have the area of the base, yes? And then I just have to multiply that by h, or your height. So 6x squared plus pi x squared times h. You could distribute it in, and you'd be good to go. Any questions to that? Again, this book does not have user-friendly answers that you guys are necessarily going to like. It's a little harder sometimes to check your work or your answers by plugging something back in. The pi x squared comes from the area of the circle, but wait a minute. I made a mistake, or we forgot to catch something, that we're not talking about the whole circle, are we? We're talking about half of the circle, so you got to divide that by 2. So be careful. Easy to make mistakes, guys. Break it into pieces. Don't forget what you're trying to find. Surface area of cones. Guys, what's surface area again? Overall area. So the area of all sides. Or faces. Some people like to say we have faces on objects. Think of a cone. A cone, guys, has a circular base that comes to a point. Yes?
Yep.
That means that you need to find the area of the cone shape
That's actually really good.
and don't forget your bottom,
It's really good.
there is a circle.
Mine doesn't look on that.
So, definition there is slant height. Slant height, guys, well, first of all, I think everybody would understand that if I drew a dotted line down the center here, it would intersect in the middle at a right angle. That's your true height of your cone, right? At any given point, I can create a triangle that has a height there, certain radius, which would be your base. Great. But the slant height is the, I think they sometimes call it the L. I don't know why L, but I think it's L. The side of the cone. Your hypotenuse, basically. Because, I don't have a lot of room here. If I was to cut this cone, cut the base off, kind of like if you guys had a drumstick, right? They're called drumsticks. I think that's what they're called.
What's a drumstick?
The waffle cone with a little chocolate in the bottom, have ice cream on it. Usually they chocolate top it. Okay. Usually it comes with a wrapper on it, right? That's a cone. You take the top off and you start to peel the wrapper back, and what you find is that you get something that looks like, oh, that was bad.
I don't think I ever seen triangle.
You've never.
It's not a triangle, but the base is kind of rounded. Yes?
If you like cut it in half.
So L is your slant height of that wrapper.
I don't know what ice cream you eat, but.
Okay? And to find the surface area of this shape, guys, it is pi r L. That's of just the top part of the cone. Right? Don't forget that when you're finding the the surface area of the whole entire cone, here, you also need to factor in pi r squared for the base. So, example number 1 there, it says the radius of a base of a right circular cone is 8 centimeters. The slant height of the cone is 10. Find the surface area. Which means, if I draw another picture, draw a circle, that there, we have 10 and 8. Yes?
Yes.
Okay. Here's the cool thing. The surface area of the whole entire thing is the circle and the little chevron type thing with the rocker. So the circle on the bottom is pi times 8 squared plus pi times r, which is 8 times 10. And you just gather it all up. Multiply it and gather like terms.
Oh, easy.
Once you know the formula, yeah, it's fine. You're not having a note card on your quiz. So, 8 squared, 64 pi, plus 8 times 10 times pi.
80 pi.
80 pi. 64 pi plus 80 pi is
144.
160 minus
144 pi.
40.
Realize that my notes are not, I'm missing some photos here of some shapes. Also, remember that surface area in general is just all the sides added up. So if I have a rectangular shape, you just need to find the area of each one of the faces and then add them up. The cylinder, on the other hand, does not have rectangular shapes. There's one of them, actually, but I have 2 circles. Now, has anybody ever taken a can apart? If you ever take a can apart, you can't see it on the video, but if I took the top off and the bottom off of a can, you end up with a cylinder still. And if I take a pair of scissors and cut straight up and unroll it, you end up with a rectangle.
Rectangle.
So the surface area, guys, of a sphere is the 2 circles and a rectangle. Now, the height of this object is still the same as the height of the cylinder. circles are easy to find. It's pi r squared. You guys know that. But what about this shape? What's the length? Where does that come from? What was originally attached to the top and the bottom?
Circles.
The circles, or the top and the bottom of the can. So, if you think about it, this box was wrapped around your top of your can. Now wait, what's the distance around a can?
360.
Pi r squared is not it. It's 2 pi r circumference. So we're going to give you 2 pi r. The circumference of the circle times the height will give you the label of a can. Something else that was left off the notes here on this, but it's on yours, is the sphere. And what it is I drew a ball and I put it inside a can. I think we all have seen tennis ball containers, right? It usually comes with 3 of them in it. What if they made a can with just 1 ball in it? Okay, I don't know, they might do that.
Well, it depends on what one you get.
So what we're going to do is we're assuming that the ball or the sphere fits perfectly inside the can. What they found was that the volume of the ball is actually 2/3 the volume of the can. Hence, what's the volume of a can? It's pi r squared, the base, times the height. So, pi r squared times h. If you call the side h, and you have a radius of r. Yes?
Yes.
That is a circle, or a sphere. Now, to clean it up, because maybe I don't have a can that's attached to this.
Excuse the interruption. Could I have your attention?
Now,
I'll figure it
wait a minute. If, say, I was just given the sphere without those other dimensions, well, think about where this height means. The height also, guys, doesn't just go to the side. It goes up and it goes down, yes? So would you guys agree that's r and r? So the height is really just 2r? Or aka the diameter. So could I use that and plug it in here? So it's 2/3 pi r squared times 2r. And wait a minute. That means I can take the 2/3 and the 2, multiply those together to get 2/3 times 2. Okay, look, let me help you out, guys. 2/1. Okay. How do you multiply fractions?
There's no problem. It's the top times the top and the
Yes.
bottom times the bottom.
So it's 4/3, yes? Pi, and r times r cubed. So the volume of a cube is 4/3 pi r cubed. Surface area is going to be 4 pi r squared without going into much fanfare of detail. So, you need to know those for our problems in your homework, and if you wanted to get through this problem here, where it's asking you and telling you you have a radius of 9.
Can you go back?
So if I ask for surface area, you just plug it into the formula, which was what again? Surface area 1.
4 pi r
4 pi r squared.
4 pi r squared, or 4 pi 9 squared? Yes?
Yes.
And area, surface area, oh, that's surface area, sorry. Volume.
What is going on?
Volume is 4/3 pi r cubed, or 4/3 pi times 9 to the 3rd power. You guys have calculators. You could evaluate that, leaving in terms of pi.
So it would be, what is that?
Homework, lesson 2, page 24, 16 through 29, all.
You didn't say
Have a great
have a
day.